Alright, so here we go. We are ready for problem number 11. Is that right? Am I in the right notes here? We're ready for problem 11? So let's see what's going on. What do we have here? Let's see. We are all excited about being in math, I can tell. So am I. Alright, well, I don't know what kind of shape this is. My drawing's not very good. But my job is to prove that the diagonals bisect each other. Okay, what does bisect mean?
They got a 90-degree angle when they hit each other.
They could, but they don't necessarily have to be perpendicular. That would be perpendicular. This is just bisecting. What does just the word bisect mean?
They like hit each other at the midpoint.
They cut each other in half, right? So he's right. If they bisect each other, then we're talking about the diagonals now. So we're talking about this and this. If they bisect each other, then doesn't that point right there have to be the midpoint of both segments? So that's how we're going to prove it. We're going to prove it by showing that they have the same midpoint, and then they bisect each other. Okay, so how do we do midpoint again? How does that work? Let's do a PR. How do we find the midpoint of PR? The average. It's very, very simple. So -7 plus 3 is -4 divided by 2. Remember, you're adding and dividing by 2. Your averaging would be -2. And -1 and -1 is -2. Divided by 2 is -1. These are all in a straight line here, horizontal line. I can't tell it from my picture. All right, how about here? -2 and -2 divided by 2 is -2. And 4 and -6 is -2. Divided by 2 is -1. They have the same midpoint, so therefore they cut each other in half. Would you agree with that? Yeah, that's pretty not so bad. All right, a little more geometry stuff it looks like. Anybody know what the standard form of the equation of a circle is?
Oh, it's like,
Go ahead, Peter.
hold on, I know how to like recognize it. It's like x minus a number squared plus y minus a number equals the radius squared.
Okay, so in other words,
I don't know how to like actually.
x minus h squared, y minus k squared equals r squared. Now, I'm using h and k because those numbers are traditionally, or those letters are traditionally used. They could be anything. They could be a and b, p and q, it doesn't matter. These are numbers. Peter was exactly right. He said x minus a number. So h and k are numbers. And then he said equals the radius squared, so we'll just call that r squared. That is the standard form of a circle. Very good. That's right. How many of you remember that? Just Peter. Thank you. Very good. Okay. Now, right, okay, so that's it for 12. There's the standard form. That's When you write the equation of a circle, that's what it's gonna look like if it's in standard form. You okay?
Me?
You alright? No, him?
Oh, yeah, I'm good.
You okay? Alright. Now, we're gonna write the equation of a circle, given this center and this radius. So in other words, you're gonna write something that looks like this, but you're gonna use these numbers. Can you do that? What's it gonna look like? X plus 3 squared, don't forget the squared, plus y minus 5 squared equals
2 times 6. 12. Oh.
24.
It's 36.
Ooh, I'm hearing 12, 24, 36. Anybody else have a guess?
24.
Okay, we're fighting about it up here.
What do you guys?
It's
what do you guys
24.
think?
It's 24.
Wait, no, yeah.
Remember, when you, this is r squared. So we have to square 2 root 6. And when we square it, we square the 2 and get 4. And then we square the root 6 and get 6. So that's how we got 24. Okay. Sarah, you're new to us, right?
Yes.
Okay. We had a discussion now twice, you're the third time. We're a no-gum school. So go ahead and pitch that, that'd be great. Don't swallow it, that's disgusting. You can get up and go over it in the trash. Okay. Good, good, good. Can you do B? Can you write the equation for B? It's a circle. I've given you the center and the radius. What's that one gonna look like?
X plus 5.
X, actually it won't be plus, it will be minus. And to help you kind of think about that a little bit, do you remember back when you solved equations like this and you factored it? Remember that? Let's see, that'd be plus 6 minus 1. Didn't the x always turn out to be the opposite of what was in the parentheses? That's a common theme in all mathematics, not just solving equations, all of it. So when you see a parentheses and you're gonna pull an x out of it, it's gonna be the opposite every time. So the center here would be 5, positive 5. All right, what about here? You can write y minus 0. You can also just write plain y squared, right? I don't care. It could even be y plus 0. It doesn't matter because it's a 0. And then what's that gonna equal? I have no idea. What's 9.1 times 9.1? Is it 82.81? Don't trust me, good grief, I'm 63 years old. My brain is tired. And I make about 1 million mistakes a day. So what do you think? Is that right?
Yeah.
Okay. There's the equation of the circle. Oh, out comes the calculator. Okay, double check us. Make sure we're right. Okay, now we're going backwards. Here's a circle. What's its center? What's its radius? Center is 3 comma negative 1/2. Oh my gosh, this is so easy. What's the radius? Square root of 18, which I heard some wonderful person say 3 square root of 2. We always reduce our radicals, we always reduce our fractions. You all right with that? Okay, now, this one's a little bit different now. We're still finding the center and the radius, but wait a second. It's not in standard form. Wasn't it easy to find the center and the radius for it to look like this? Yeah, okay, Tess, what do you think?
If you add 14 and then complete the square.
We're gonna complete the square, very good, we're gonna complete the square on our x's and on our y's. And in order to complete the square, that 14 has to be over here. You are exactly right, Tess. Very good. Now, here comes a bigger question. Well, first of all, when I complete the square, I'm gonna add a new number to make this into a square. That's why it's called completing the square. Whatever new number I add here, I also have to add on the other side, right? Don't forget about that. That's a really common mistake. Now, who remembers how to complete the square? Mr. Fahey?
Divide by 2 squared.
So we divide this by 2, or take half of it, however you want to think about it, and square it. So it's the linear term, the x term, the b term in terms of ax squared plus bx plus c. So we take half of 12, which is 6, and square it, and we're gonna make this 36. Do it on both sides. Now, the reason you did that is because this now factors into what? X plus 6. Now do exactly the same thing with the y's. So half of 10 is 5, squared is 25, so that's going on both sides. And what's my y parentheses? Y plus 5. Squared. And then I'll add all this up, and this will make 75. So now it's easy. What's my center? -6, -5. And my radius is? Square root of 75, which is 5 square root of 3. That's exactly right. All right, you see, check your answer with your partner. Now, none of us are freaked out about the y part of that problem, right? Because since there is no regular y term, you don't need to complete the square. It's already a perfect square. Y squared is a perfect square. So the only square you have to complete is the x. I got a center of 2, 0 and a radius of root 2. Anybody else get that? Whoops. Did I miss it?
No, I'm just looking.
Tell me, did I do something up there that's confusing? You're not sure about?
No, that's all right.
The reason we complete the square, kids, is because we have something like this that's messing everything up. Without that, y squared is already a perfect square, y minus 0. Did you guys talk about the other conic sections last year? Did you do parabolas, hyperbolas, and ellipses? So you did this kind of stuff? All right. Just wanna stare at me. All right, number 15. Here we go, number 15. Write the equation of a circle. So we're writing something like this. The equation format Peter gave us earlier. We're going to write the equation of a circle. But this time, what we know is that the diameter has endpoints at 2, 7, and 6, -13. Now, I know I didn't plot those, I know they're not right, relative to each other, but that's not that's irrelevant, it doesn't matter. I need to write the equation of a circle that has a diameter with those endpoints. So think about that, what do you think? Emma? Schnurr?
Well, we can find the distance and then divide that by 2 to get the radius.
Okay, so Emma says, in order to write the equation of a circle, I need to know the radius, right? So she says, hang on, there's always more than one way to do a problem. This sounds fine to me, this will work, right? To get the radius, she says, let's find this distance right here. So how do we do that again? How do we find distance?
Average.
No, distance is an average. What's distance? That's your big square root, right? So 2 minus 6, and, 7 minus -13. Great. So that's gonna be what? That is 4 squared 16. That is 20 squared 400. Oh, did I do it wrong?
That's right,
No,
yeah.
I'm just,
So I got the square root of 416, I'm just gonna leave that for a second. That is my diameter. So my radius will be the square root of 416 divided by 2. Now wait, I know that simplifies, but just hang on. Is that so far so good? Okay. Sydney.
so are like diameter and distance here like the same?
The length of the diameter is the distance from this point to this point.
And that's what, that equation is that we
Yep.
were trying to find, okay.
That's the distance from here to here.
Okay.
What else do I need to write the equation of a circle? I need the radius, which I have,
The center by finding the midpoint.
and the center's gonna be the midpoint. Would everybody agree with that? So, midpoint is average. So 2 plus 6 is 8, divided by 2 is 4. 7 and -13 is -6, divided by 2 is, so now I have my center and I have my radius. So what will the equation of my circle look like? X minus 4 squared plus y plus 3 squared equals 416 over 4?
Over 2. You square bottom.
No, you square it.
Gotta square the whole thing, right? Square the whole thing, r squared. Now, this is the reason I didn't break that radical down, because I knew when I wrote my equation, the radical was gonna be gone anyway. So now I can just simplify that. X minus 4 squared plus y plus 3 squared equals 104. Now, let's stop here. Anything up there, did you make any mistakes, or are you confused about any of our steps? Now, somebody back here had a hand up, right from the very beginning, or maybe it was there, someone had a hand up right from the beginning, because I think you didn't wanna find this distance. Now, did we get the mission accomplished by finding this distance? Sure, it's fine. What else might we have done?
Found the center first and then use that.
Found the midpoint first, and then found that distance. Now, it's not really gonna save you anything, except you're not gonna have to do the divided by 2 thing. And notice that if you did that, this distance, 4 minus 6 is 4, or 4 minus 6 is 2, squared is 4. -3 minus -13 is 10, squared is 100. So what do we get for our radius? The square root of 104. So when I wrote my equation, I would get r squared would be 104. So it's fine to do it either way. Remember, if you do the diameter though, you have to divide by 2 to get the radius. Okay? Josh, are you a soccer player?
Yep.
Okay, tell me what happens when you sit on the bench and you slouch all down like that, you put your head back like that. Does the coach say, hey, go in now? No. He says, you're now JV. Right? You do not want to be a JV math student. Let's be alert and attentive. This is not JV. Okay. All right, P2 homework will be due on, what's today, Tuesday? It will be due on Thursday. So P2's due Thursday. Here we go, ready to move forward with P3. Yep, no slouches today. Here we go, we are varsity. All right, anybody know any of these properties? These are properties of equality. The other day, we talked about properties of addition and multiplication. These are properties of equality, so let's run through them. Notice that we don't discuss properties of subtraction and division because we don't need to. Subtraction is adding the opposite, so the properties of addition cover that, and likewise with multiplication. So here we go. Who knows any of those words? What do any of those words mean? Sydney.
Okay, is symmetric like A equals B? If A equals B, then B equals A?
That's exactly what it is. The symmetric property says if A equals B, then B equals A. Perfect. Do not get that one. It's an order thing. Do not get it confused with commutative. Commutative is an operation, so it would be A plus B equals B plus A. See the difference? These are properties of equality, so we're making changes in an equals situation, not an add or times. Peter?
Is transitive like A equals B, B equals C, which means A equals C.
Okay, so it's another if-then statement. What, by the way, what do we call an if-then statement? Well, we do them in proofs. You studied them in geometry. It's called a conditional. A conditional. So if A equals B and B equals C, then A equals C. Very good. That's exactly right. That is your transitive property. The if, and then are important parts of the property, so be sure you're including the words. All right? Reflexive, addition, or multiplication. Anybody know any of those? Sydney?
Okay, I'm going out on a limb here,
Okay.
but addition is that if A equals B, then A plus B equals B plus C.
If A equals B, then A plus C equals B plus C. That's exactly right. And you use that one all the time. Don't we add the same thing to both sides? We just did it when we completed the square, right? You're allowed to do that. You're allowed to add. And then this one says, if A equals B, then AC equals BC. Multiplication. Perfect. We're missing probably the easiest one of all. What's reflexive, Danica?
Isn't it just like A equals A?
That's exactly what it is. This is A equals A. So something equals itself all the time. All right, those all look familiar. You did them in geometry a lot. I don't know how much you did them last year, but you used them all the time in geometry. Number 2, I just wrote down the definitions. A linear equation, ax plus b equals 0. A and b are real numbers and a can't be 0. That's what we mean by a linear equation. A linear inequality, I'm talking about in one dimension now. I'm talking about on the number 1. A linear inequality is ax plus b either greater than or equal to, less than or equal to, or greater than or less than 0. Easy. What are the properties of inequality? These are the properties of equality. Now, since I have them written up here, if they're a property of inequality, we should be able to change the equals to, let's say, a less than. Is that true? No. So there is no reflexive property for inequality. Is that true? Nope. So there is no symmetric property for inequality. Is that true?
Yes.
I'm randomly using less than, I could be replacing with greater than. That's true. This is the transitive property of inequality. All right, what about this one? Yep, Dom's back there shaking his head up and down, nodding his head up and down. He's right. That is absolutely true. Absolutely true. So that one works. Alert, alert, alert. This one is true if what? If C is a positive number. What happens if you multiply both sides by a negative number? It switches the sign. So if C is positive, that's a true statement. If C is negative, then AC will be greater than BC, right? Be careful with those crazy inequalities. That's why I have a little star next to the multiplication one, because we have to clarify whether we're multiplying by a positive or a negative number. All right, now we got a bunch of equations and inequalities to solve. So how about if we do this? Let's do 2 at a time. This should not be hard for you. I'd like you to come up. If you are a little unsure, a little timid, bring a friend with you. But let's get 2 of these done at a time. So everybody, if you're not at the board, you're doing it at your seats. And let's see what you want to do with this first one. And the second one. All right? Huh? Come and do one. No, do it right now. Just come up and do it. Please use a black marker and write nice and big. All right, who's my other volunteer gonna be? Let's have a girl. Girls? Zoe? Grab a friend if you want, or come up by yourself. I want you to do this problem. on the board, okay? Nope, you're on board.
Sometimes everybody in that case.
I haven't done this, so I'm gonna do it too, and we're gonna see how we do. You got them both done here? Yes, okay.
Oh, it's 16.
Oh, do you get negative 7
Good job, guys.
Oh.
Just the same. I mean, I wanna try and do one. Wait, there's only two.
Divide by the coefficient.
I thought she. Wait,
All right. How about number 1, guys? Y equals 6. Y'all good with that? No issues? Everybody dealt with the fractions? He multiplied everything by 8, and even though he wrote it over here, he also multiplied this by 8. You have to multiply, if you choose to multiply, you have to multiply everything. So he did. I think that's gorgeous. Does anyone have a question about it? That's what I got. Everybody okay? All right, how about this one? She distributed perfectly. Collected like terms here. Looks like what? Subtracted 3x and subtracted 6. Now, when I did it, my answer came out looking like this. Because I have an issue with my variable coming first. Does it have to? No, but I'm kind of anal that way. I like to have my variable first. These are exactly the same. Now, one just bit of caution. Normally with an inequality, we're gonna write our answer as an interval. Okay? Because that's what calculus students do. So this is fine, this is the answer, but as an interval, keep in mind, so that even though your arrow is pointing this way in your answer, when you graph that, it's actually going to be pointing this way. So your interval is going to be -7/2 infinity. Does that make sense to everybody? We're not gonna make any goofy mistakes and arrow the wrong way or anything like that? Perfect, you guys are amazing. All right, well, let's do the next two, C and D. I need new volunteers. So you're not volunteers if I have to call on you, so please, let's do new volunteers. If you don't wanna come by yourself, bring a friend. Gotta be new people though. Let's use black markers and write big. Shows up there. All right, there we go. Who's doing what? And you're all doing to make your seats. We're checking to make sure we're right. And you guys both have inequalities, so would you write your answer as an interval?
This one got bigger numbers. What I do different. I break them out. I don't think it's own. Like that. And I think we have more class.
That's fine, that's absolutely
I
fine.
don't like the triple.
Nothing wrong with
Double.
that.
Oh my gosh, bro, it's really too far.
Oh, yeah.
So you used to be these two big.
Oh, you should put, do you want us to put it in
All
the
right.
application?
That's what the
Let's take a minute, let everybody catch up. You're all doing 2 problems, they only did 1, so let everybody catch up a little bit. Check these over.
Oh, I said negative. I said negative 9 minus 5 was negative 4.
I separated.
You can,
I like this picture.
Now, you may have done it differently, than they did, but are you getting these answers? These answers look okay? I love this. I love the fact that she just left it alone. She didn't break it apart or do anything hard. She just left it alone, times everything by 3, subtracted 5, and divided by 2. That's beautiful. And so her answer came out exactly. X is sitting between negative 7 and 5. Beautiful. Anybody have a question about that? Now, if you did split it up, you would get that same answer, or you should get that same answer. If you split it up. Look at the next one, you guys. What about problem E? It looks a lot like Marin's problem, but what? There's too many X's, right?
Was C X is greater than
Negative 2. So let's talk about this one for a second. I would love to do what she did, and I actually can multiply everything by 7. So if you want to do that, that's perfectly fine. Then you don't have to worry about a fraction anymore. So that's okay. Timesing every single thing by 7, hopefully correctly. But there's really no way now of getting X in the middle by itself. So what should I do? What am I gonna do?
Separate the,
I'm gonna have to separate them. And when I separate them, there is a very important word we have to include. So one of our inequalities is right here. Would you agree with that? And that's a very important word, and the other inequality is this. Now that word is important because and means that whatever answer you come up with has to be true for this one and this one both. All right, so let's solve this one. What do we get? Okay, I don't know. It's the end of the day. I have no idea. I got X is less than 22/9. Does that seem okay? And then over here, I don't know.
If your X is negative, X is right.
I got X is greater than 36/37. So whatever my answer is, it has to meet both of those qualifications. So here's 36/37. Here's 22/9. I gotta be bigger than that one, but less than this one. Do you think I'm in between? What, I think I'm right, but double check my arithmetic.
Yeah.
So my answer is the interval from 36/37 to 22/9. Now, caution, because if I randomly make up a problem like this, it's possible that there will be no solution. Do you see how that could happen? Because, for example, if this had been, if these signs had been reversed, now they weren't, I'm just saying suppose they were. Are there any numbers bigger than this one and less than that one? No, so that would be an empty set. That would be no solution to that problem. Because whatever it is, when you split it like that, they have to satisfy both. All right, one more in this section. Go ahead and do that last one on your own. Compare your answer with your friend. Oh, I guess there's another on the back side too, that's right. Let's do F, see what we come up with. Now, are we gonna write that one as an interval? No, because it's an equation, so x equals, what does x equal? -5/7. All right, one more, now we got one more of those. Anybody wanna come up and put this last one on the board? Somebody who hasn't already been up? I'll give everybody a chance. Thank you. Is it Alexis? Thank you, Alexis. Perfect.
Less than 76.
That's true. Go ahead and write your answers in interval too. Oh, yeah. Thank you.
Less than 7, so it's
All right, take a look at that. Guys, are you looking at this? Don't be little lemmings. Don't just follow each other off the cliff.
The interval is wrong.
it should be negative and then.
When I solved it, I got the same thing she did. I got this right here. That's the right answer. Now we need to write that as an interval. And it doesn't matter to me, but I always think about and suggest to you, think about the picture. What does that look like when you graph it? So Alexis, you see what happened? Yes. You were going the wrong way. So our interval should actually be negative infinity to 7,6. Is that right? We're gonna do a couple more problems, and we're gonna do something different. Let's get out of our notes. We're gonna skip 5 for a second because I forgot to ask you to bring your calculators. So I need everybody to bring your calculator for our next class, okay? Graphing calculator, because we're gonna graph. Remember, if you can't get one, you can't afford one, your mom bought one and you lost it, so now she's mad. something. I have a very few that I can rent to you just like, or loan to you just like the library did. Okay, you check them out from the library, check them out for the semester, is your obligation, goes on your bill, $120 if you don't return it. So if you're in that situation, just hang out after class and I will sign you out one, all right? But if you have your own, that's ideal, having your own, great. If you're going to go buy one, make sure it's a Texas Instruments. We are a TI school, don't be messing around. I know the Casios are cheaper, but nobody here knows how to use them. The only person that knows how to use a Casio calculator is Mr. Knoll, and he left. So, if you have a Casio, you're on your own. It'll work, but you're on your own. All right, I want to skip 5 and look at 6. Solve for the indicated variable. And then we're going to do 5 next time. All right, what's this? What's that? Area of a trapezoid. This is the formula for the area of a trapezoid. It's all letters. There are no numbers. Well, I guess there's a half in there, but it's all letters. And your job is to solve for H. So we want to get that H by itself. So in other words, we want to manipulate the equation and end up with this. Okay? We need to do this all the time in calculus class. All the time. You need to rearrange your equation so you have one letter, a different letter by itself. We have A by itself now, we want H. So what would you do first if this is you? What would you do first? Let me do Emma?
Would you times A by 2?
I would get rid of that fraction. You don't have to, but I think that is a great suggestion. Just get rid of that fraction. Perfect. Now what? We're almost there. Tess?
Divide by B1.
So H is gonna equal 2A over B1 plus B2. Now, let's be honest, normally we have to include, like, we got a division problem here, we have to say that these two can't be opposites of each other because you can't have a denominator of being 0, but will either of these ever be negative? No, so I don't need to worry about it, that denominator is gonna be fine. All right, one more. What's this one? What formula is this?
Area, volume sphere.
Volume of a sphere, that's exactly right. This is the volume of a sphere. You know what a sphere is, a ball. This is the volume of the ball. And we want to solve for R. So George, what would you do first?
I would multiply both, divide both sides by 4/3, just get the fraction out.
Okay, so dividing both sides by 4/3 is the same as multiplying both sides by 3/4. So 3/4 V equals pi R squared. Now, in case it's going to confuse you later on, this is the same as 3V over 4. Would you agree with that? So you can write it this way, or you can write it this way if it's easier for you. All right, now what? Now what? Got to divide by pi. Now when I divide by pi, it's going to go right down here with the 4. Because I'm like multiplying by 1 over pi. So 3V over 4 pi equals R cubed. And then what's R? The cube root of 3V over 4 pi. The radical is the whole shebang. All right? Okay, that's enough for today.
Yep.